Okay, number of neutrons. As promised, how to work out the number of neutrons. Okay, so lithium. This is what you'll find on the periodic table. Now, these numbers can be either way. The periodic table that I had before had the atomic number at the top and the mass number at the bottom. Generally, it's done this way around, but all periodic tables will tell you. But the easy way to figure it out or to remember it is that the smaller number has to be the atomic number, and the other number, the bigger one, is the mass number. So the atomic number is equal to the number of protons. The mass number is equal to the number of protons plus the number of neutrons. This is cool because if you know that the mass number is 7 and you know that there are 3 protons, you can work out the number of neutrons, and I'm going to show you how. Okay, so we've got our nucleus, which has protons and neutrons in the middle. How many protons does it have? 3. 3 protons. How many electrons does it have then in a neutral atom? 3. 2 in the first shell and 1 on the second shell. So it's got an electron configuration of 2, 1. Nice easy one to draw. Okay, I've just blown up the nucleus here so that we can see what's happening inside. Now, what's in the nucleus? We've got 1, 2, 3 protons. So the other particles in the nucleus must be neutrons. The total number of particles in the nucleus is 7. So we've already got 3 protons, so we'll need 1, 2, 3, 4 neutrons. That gives us a total of 1, 2, 3, 4, 5, 6, 7 particles. The number of neutrons equals the mass number minus the atomic number. So all I've done there is rearrange this formula here. Mass number minus number of protons, or the atomic number, is equal to the number of neutrons. Let's look. Mass number, which is 7, minus the atomic number, which is 3, equals your number of neutrons. 7 minus 3 equals 4. So the total number of particles is equal to the mass number. So all you need to do to find out the number of neutrons is to subtract the atomic number from the mass number. So I've got another example. Boron. Mass number 11, atomic number 5. Atomic number is the number of protons, and the mass number is the number of protons plus the number of neutrons. So we can draw this. How many protons does it have? 5. Neutrons is what we're going to try and find out. We've got 5 electrons. 2 in the first shell, 1, 2, 3 in the second shell. So it's got an electron configuration of 2, 3. We want to look at what's inside the nucleus. Okay, so we've got 1, 2, 3, 4, 5 protons in the centre. There's a total of 11 particles in the centre. So how many neutrons do we need? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I've now got a total of 11 particles, which is what my mass number is. 1, 2, 3, 4, 5, 6 neutrons. Or we can work it out. The number of neutrons equals the mass number minus the atomic number. So the mass number, 11, minus the atomic number, 5, is 6. Mass number minus atomic number equals your number of neutrons. 11 minus 5 equals 6. So you can now draw any of the elements up to calcium, which is number 20. The other thing I do need to point out is when you look at a periodic table, a lot of the mass numbers are in decimal places. Now, I'm not going to get into why that is now, but just round it up or down to your closest whole number when you're working out how many neutrons are present. You'll find out a little bit later as to why that's a decimal place. But at the moment, as I said, just round up or round down to the nearest whole number.